Good morning again, y'all. Uh, today's episode of the complex series is Linux shell scripting. Oh, sorry, let me pop this off here. Um, my name is Nicole Walter. I'm part of the complex team here. I'm also part of the data-enabled scientific computing team at SDSC. And when I'm not doing training, I'm doing user support for the HPC systems we have and the cloud systems that are available here. The two links at the bottom, I think you saw them on the previous screen as well, are where you can find um, all our materials. So both the slides will be available there and any hands-on material that you can later go back and use. So for those of you who haven't joined us before, I'll just give you a very brief review of what Complex is. Complex is an SDSC training program. We're now in our second year, and it's going to cover all the most important, what we consider the most not important non-programming concepts and skills needed to effectively use supercomputers. So we saw that there was a need. Traditionally, the people who used HPC systems were doing hard code parallel programming, and so a lot of the training material was focused on that. And we found that over time, the majority of people are not writing their own code, but rather need these other skills to simplify their lives, make their lives less frustrating, and make their workflow more efficient. So what I'm talking about today is Linux shell scripting. So I don't know where everyone's level is, so I'll do just a really quick recap on what a shell is, and then I'll talk about the generally shell scripts. And then I'm going to work on the specifics of shell scripting and how to do shell scripting, because the different shells have different syntax. I'm specifically going to use Bash shell scripting. I'll talk a little bit more why we chose Bash shell scripting in a later thing. Then we'll finish up, and I'll have time for some Q&A at the end. So whenever we develop these, we have we make some assumptions about who we're talking to. And so some of the assumptions that are made when I developed this slide deck was that everyone who's attending here is familiar with Linux basics. So, basic Linux command line tools. So listing files, removing files, navigating through directories, listing contents, managing file permissions, and that you have some basic concepts of some parallel, some programming tools such as loops and redirection. And then if you want to do the hands-on material, we assume that you have the ability to use one or more standard VI editors. So because I'm not sure if this assumption is correct, I want to throw out another little poll just for our future reference, that if Cindy can do that real fast, just to know, are we making correct assumptions? So just a really quick refresh on what a shell is. It sounds like most of you already know this, but a Linux command line is provided by a program called a shell. A shell is a command line interpreter that has a programming language with it. So it's going to allow users to interact with the operating system by typing commands and executing them. So you can use shells interactively or non-interactively. You can run commands synchronously or asynchronously. But one of the really cool things about it is that there's an embedded programming language. Excuse me. So like any high-level language, the shell provides the ability to create variables, utilize flow structure, control structures, create functions, and things like that. And because we have a programming language, it allows us to do scripting. One thing to note is that on your systems, there are several different shells that are there. The different shells were, again, devised by folks who wanted different functionalities in them or didn't like the syntax that was in previous shells. So you should be aware of the shell that you're in and the shell that you're using. And when you're choosing a shell, you should pick one that is best for your application or workflow. The thing that is going to affect when you choose a shell is how you execute the programs, what system resources you have access to, and importantly, the syntax. So this is a non-comprehensive list of all the shells that are out there. I'm only going to refer to two of them in just so that we don't get bogged down in the weeds here. So the first shell is the Bourne shell. Most of the other shells are derived out of it. As I mentioned today, I'm going to use the Bash shell. Bash shell literally stands for born again shell. And it has some additional features that the Bourne shell does not have. So if you don't know what shell you're currently in, you can always find the shell by using the $0 sign. This, as we'll discuss a little bit later on, the $0 is a special parameter that will be used. You can also sometimes tell which Unix shell you're in by the command prompt. Unfortunately, a lot of them do use the $sign as the command prompt, but I bring this up more specifically because the $sign is also a special character in Bash shell. So in my examples later on, I want to ensure that it's a clear distinction that there is a command prompt and this additional special character that's being used. For the shell scripting that we're doing today, it doesn't necessarily matter what your default shell is. You can run a shell script from any of the shells as long as it's available on your system. So to find out what is available on your system, there's two commands you can use, and both of them return the exact same information there on I guess, the right side. So you can use the change shell command with the listing directive, or you can actually cat the shells directory. A thing to note is that you'll see that there are several shells that are like Bash shell is available, but it's in two different locations. That'll be important a little later on. So shell scripting specifically. Shell scripts are programs that are executed by the Linux shell. Shell script is a file. It's a plain text file that contains a sequence of commands that are executed by a shell program, and they're executed line by line. So this allows you to perform a series of actions, such as navigating through directory, creating folders, launching processes. Essentially, you can do whatever, you can use any command that you use on the command line, you can use in a script. So the scripts are very versatile, and so it allows you to handle file manipulation, data monitoring, text printing. We have the ability to do conditional operations, looping functions, again, command line arguments. And one of the really cool things about the scripting language is that you can call other programs through it. And this is a really powerful asset. So who is using these shell scripts? System administrators use it, user support uses it, and end users use it. For system administration, it's really great because they have to do a lot of routine tasks. So some of the routine tasks that they have are backups, monitoring system resources, doing the account management, doing system setups. For user support, I'll give a specific example and plug our hands-on webinar in the 2-day workshop in 2 weeks. So for these, the hands-on part, we are going to provide training accounts, and these training accounts are training accounts that we reuse for different training purposes. So we have scripts that will go in and clean them up. Obviously, if somebody else uses it, we need to make sure there's no secrets in them, that the environments are clean. And we can also, with these scripts, we can put aliases in so people don't have to write long commands. We make sure the environment is set up. We can fill the directories so that they don't even have to download files and everything is available for them. For the end user, it's great because it's good for software development. You can build and deploy applications. You can run tests using these scripts. You can manage dependencies. You can do prototyping to help you debug more complex applications. In today's day and age, we have, large data sets and I don't know, depending on we're overflowing with data and we have a lot of machine learning. In a lot of those cases, a lot of time is spent dealing with what some people call data wrangling. So putting the data into the correct format so that it can be used by whichever application you're going to be used. So automating the ETL process is a huge benefit and saves a whole lot of time. Last thing I'm going to talk about here is the task scheduling. So there's two types of task scheduling that I'm going to talk about. The first one is that for system administrators, it's really nice that you can actually automate your workflows with these scripts by adding them into cron jobs. I'll talk specifically about cron jobs later on. But the other thing with task scheduling is if, as many of you mentioned, that you've already been running on HPC systems, and so your batch scripts are essentially shell scripts. It sets up your environment, tells everything to do, so you're already familiar with shell scripts a little bit. So what are the advantages to scripting versus other things? First and foremost, it's pretty simple. If you're currently working on a Linux machine and you run commands on the command line, that is the language that you're going to use. You don't need to learn different syntax. You don't need to learn anything new. When you write the bash script, there's only one additional mandatory line that you have to add that details which interpreter you're going to use. But other than that, it's everything that you're currently using. It's really quick to write these batch scripts. Again, there's only one additional line you have to add in there. They're not compiled programs, they're plain text files. So to debug, you don't have to compile the program. They're portable. I'll talk a little bit more about this later, but if you use the shell scripting for what they're kind of intended. So if you don't get too complicated, they're really very portable. So any system that's running a Unix-like system, you can port it to them with minimal modifications. The huge advantage is the reproducibility. I think if you talk to any system admin or any user support or anyone who's using the system for a long time, essentially they will write a script for any series of actions they have to do more than twice. So this is great because it simplifies. You can bundle all your commands together and you can run them with one command, or you don't even have to write that command because you can throw it in a cron job and then it will automatically run for you. And because you've pre-typed it and you've pre-tested it, you're never going to have any fat finger errors because you typed something incorrectly. On the flip side, because it is simple, it's also simplistic. It doesn't do error handling very well. It doesn't support complex data structures. So it's not going to be well suited for database tasks that require a high level of database access. In general, it's really just not suited for large complex tasks. Performance. There is no tuning that you're doing in your shell scripting. Like in compiled programs, you can specifically compile for a specific architecture. You're not doing that. So the performance, you're not going to be able to tweak it and get and eke out a lot of performance out of these programs. So some rules of thumb are if you're mostly calling other utilities and doing relatively little data manipulation, then these shell programs are a great option. Also, if it's a small program. So I was looking around to see kind of where the cutoff was, and online it seemed to think that less than 100. I think 100 is a lot, but definitely if it's less than 100 lines of code, then it's still appropriate to do a shell script. The last thing I'm going to talk about is quality, and quality doesn't necessarily reflect on shell scripts themselves, but rather how people use the shell scripts. Very often they're very quick hacks. They're not well documented. So they could be reused, but you have to go in and check on them. So it tends to be that shell scripts don't have great quality, but we would recommend that you take the time and do some due diligence to make sure that they are good quality and you could hand them off to other people. So there are some bash shell conventions that are going to promote script reliability, maintainability, and portability. And I'm not going to go into too much detail on them. I do have a link here to a guide that will help you to do the style guide. I also have it at the end of in the reference section. But one that is highly recommended is to make sure that you name your script with the .sh at the end. It is a plain text file, so it doesn't matter what you call it. You can call it anything, but at a later date, if you're coming back, if you have that .sh, you know that it's theoretically should be executable. in addition, scripts, shell scripts do not need to be executable in order to run them. So you can run them in a couple ways. Either you can make them executable and run them with the /script.sh. But if you want to write a few more, use a couple more keystrokes, you don't need to make it executable. And then you can use the source command and then the shell name, or the sh command and the shell name. Specifically today, because we're using bash, you can also use bash. To make scripts executable, I'm gonna just gloss over this. I just want to remind everyone that in Unix we have file permissions and the granularity. You can manage the file permissions on a user level, a group level, and an other level. So again, if you want people to be able to see it, write to it, or edit it, you'll have to use this change mode command. So fundamentals, shell scripts can be as simple as a list of the Unix command. They're plain text files, they contain commands, and they contain comments. The first line is the only hard definitive line that needs to be included in all shell scripts, and that first line is going to define the shell that's going to be used. After that, you can follow it with any series of Linux commands and comments in any which order you would like. All commands start with a hash, and that indicates that what follows is not going to be executed. But it should be noted that just because there's a hash, it doesn't mean they're being ignored. So the first line in any shell script will be the shebang line. So the shebang is this hash not, or hash bang. And so this instructs the operating system on which interpreter you're going to be using. So just a reminder, an interpreter is a program whose job it is to execute commands from a higher level language directly instead of having them compiled into machine code. Again, this is why we don't need to have things executable. So there's two different shebangs you can use. You can either use, you can pull the information from the environment, or you can hard code specifically which shell you're going to be using. This is where I mentioned before where I pointed out that there are multiple different versions of the shells available on a system. So if you use the environment, the nice thing is that you don't need to know where the bash is located. You tell it to look for a bash in your current path, and it will find the first bash in your current path. So this is nice because it does the work for you. You don't need to know anything. So when you go to another system, you generally don't have to change your code at all. However, there are some disadvantages. You don't know specifically which path you're using. So if there's multiple versions and there's some variation on them, it could cause you some problems. The other is that you can't add inline parameters to this. So there's a couple of parameters that you can add when you use the absolute path. So you can add some commands to include some debugging. You can also use the -r command to do restricted mode shell, which adds another level of security because it restricts what users can do in that shell. So the absolute path is great, but because it adds the security, you have this flip of security versus portability between these two. Well, just a little bit more on comments. Again, lines beginning with the hash is a comment, and they won't be executed. Comments can be on a line all on their own. They can follow a command. They can follow white space. You can put them in a pipe. The one thing you cannot do is you cannot have a command follow a hash, because again, the hash is indicating that's a comment. So anything after that is going to see as a comment. So it's not going to recognize any commands after that. There is, you can use hash as they are if you quote them or if you escape them. So why did we decide to use a bash shell? In our introduction slide on complex, we told you that this training was based on helping users for HPC to facilitate working on HPC. And so most HPC systems run on Linux-based operating system. Most, I should just say all. And Bash is currently the most common shell that's out there. When we do the hands-on for our training, it will be on Expanse, and Expanse has Bash as a default. There are some great features that come with Bash. So you can have command line editing and history. It allows you for job controls. So it allows you to run commands in the background. You can manage them. You can suspend them. You can resume them. You can also terminate them. I have this next line in quotes because I got this from somewhere and it says everything and nothing, but it's not my own words, so I need to put it in quotes. Unfortunately, I don't know where I pulled it from. So it's a robust scripting syntax with rich feature set. It has extended facilities for shell arithmetic and parameter expansion. You can do aliases, you can work with arrays, you can do brace expansion, pattern matching, and conditional expressions. So let's get into actually learning how to define variables in Bash. A variable just lets you store data. Variables can be used to read, access, and manipulate data in your script. They can store numbers, characters, and strings. One thing to note is that the numbers are generally integers. However, Bash does have a facility so that you can work with non-integers by using the BC command, which essentially invokes a scientific calculator. You can actually do it on the command line. You type BC and then anything after that is your scientific calculator. But you can also use it piping it into commands in scripts. Important to note that there are no data types in Bash. So how the variables are interpreted is based on the operators you apply to them. There are conventions that you have to adhere to with variables. They can only contain uppercase, lowercase, digits, numbers, and underscores. You cannot have any spaces in your variable names. In addition, variable names should start with a letter or an underscore. In general, when you're using variables in any programming language, you should make sure that they are useful descriptive variable names. Using case sensitivity, so just changing the case is sometimes tricky because it's error prone, but it should be noted that the variables are case sensitive in Bash scripting. Spaces in general in Bash are the shell is very sensitive to spaces. It should also be noted that there are some keywords that cannot be used, like if and else, and that variables will have scope in the shell and in the shell, and there are local and global variables. So there are special parameters, which I mentioned on the first slide with the $0, which returned your shell. The shell treats special variables specially. These parameters can only be referenced, and you cannot assign anything to them. These parameters represent positional parameters, special characters, command line arguments, and exported variables. So let's look at a couple of the special variables out there. This is, again, not a comprehensive list, but some of them that are very useful. I find them useful both for documentation purposes and for debugging purposes. So the $# is going to return the number of parameters that were passed into a script. The $@ is going to save into a hash the command line parameters that were passed into a script. The $? is good for debugging. It's going to tell you the exit status of the last process. The next three, the $, the $user, and the $hostname, are often very useful if you want to have unique file names. You can use these variables to create files. Again, if you're concerned about performance or just want to evaluate performance, you can use the $seconds. And the last two, random and line number, are just always useful when you're doing code and writing code. So let's go into how you use these variables. Again, variables can be characters, digits, numbers, or strings, and there's no spaces. So the second part of this, I'm gonna focus on what the spaces represent if you use them. But first, the variable syntax is the variable name equals the value. Again, no spaces can come in between them. You can string them together, variable names. You can have variable name equals value, a space, and then the next variable. That's totally acceptable. Making sure you define good variable names and making them unique is important because, again, it's very easy to overwrite variables because you simply change the value by redefining the variable. When you want to retrieve the information that's in that variable, you use the $sign. So echo $sign variable name, in this case, will return the value 2. So now let's talk a little bit about those spaces. So for an example, just an example, string 1 is going to be my name, Nicole. I'm going to echo the string. It comes back as Nicole. In the next two, I put a space either after the string or after the equals. And you'll notice that the errors that we get are slightly different. The first one says that string 1 command is not found. The second says Nicole is not found. So the difference between the two is where the equal is. So the equal makes it seem like a command. So either Nicole is the command or string 1 is the command, but it's actually defined as nothing. So the space is trying to indicate that there's a space and then the next command is coming. So as you see below, the string 1 equals Nicole, string 2 equals Ben. And if I echo string 2, it brings Ben up. So let's talk a little bit about scope. For those of you who haven't done a lot of programming, the scope of a program or script is usually the region where is always the region where the variables have their existence. So normally, if a variable is declared like inside a function, then it's generally considered a local variable. And if it's declared outside the function, it's considered a global variable. This is not the case in Bash. In Bash, it's, again, very simple. If it's defined as local, it's going to be local. If it's not defined as local, it's going to be global. So here's just a quick example. And I'm jumping ahead of myself a little bit because I'm going to use a function that we haven't discussed yet, but these will come back. So the first thing I do is I define a variable as strawberry because I didn't specifically say it's local, it's going to be global. Then in my function, I'm specifically defining it as local. So banana is going to be a local variable to the function. Cherry is going to be a global variable, again, because I didn't define it specifically. How functions work is you define your function and you call your function. So when I type my fun, it will define this. So the first thing we're inside the function. The first fruit, which is the global variable, so it finds strawberry. The second fruit, which is a local variable, but we're local in our functions, so it finds banana. Then we drop out of the function. We try and recall all those variables again. So we'll see that the global variables strawberry and cherry show up, but the local variable to that function banana is empty because again, it's out of scope. There are in shells in general, there are different levels of scope. There's environment scope, shell scope, function scope, command scope, and subshell scope. The environment scope, if you want a variable to be available in the current shell, any immediate sub processes, and any subshells, you'll need to use export. Again, export is specific, to Bash. You can use shell scope, where you just define the variable with an X, and this is going to make sure that it's available to the current shell and any subshells. Function scope we saw in the previous slide is where we declare it as local variable within the function itself. Command scope you can do just for the command line. So if you just do X, a space, and then the command, only the command that's going to be used is going to see that. And subshell scope, if you open a new shell, so it is a new shell, it's going to have all the same features of the shell scope and its own environment scope, but the subshell, if you open it from within the shell, nothing's going to creep back up into the parent shell. So now that we know all about our variables, what can we do to the variables? We have arithmetic operations we can do and string operations that we can apply to them. So let's talk about those. We'll start with the arithmetic. So the if you want to do expansion on it, the command, or if you want to do any arithmetic, you need to put it in these double parentheses and start with the dollar. That's the format that you need to use. So you can see on the right here, the example of var is into and numbers. There are several operators available. So the plus, minus, multiplication, division, exponential, modulus. As I mentioned before, generally those operators will work on the numbers as integers. So if you want to do non-integer work, you do need to use the BC command, which invokes the scientific calculator. So we'll just do a quick example of and show you what all these things do. I used numbers that would help us show the difference between the integer division and the scientific calculator division. So I used 8 and 3. Addition, subtraction, multiply are all pretty much as expected. The divide, 8 divided by 3 comes to 2. So it just returns the integer. If we want to have decimal places, then we can use the BC commands. So the BC command is within these quotes and these errors, we are sending this command. The scale 2 is saying that I want to evaluate to 2 decimal places and divide this, and I'm sending it to the BC command. And then we see that we get actually the number with 2 decimal places. We can also do string and command substitution. So with string operations, I mentioned before that you couldn't do spaces. However, if you use quotes, you can use spaces. So in the name, I use the best of the best. You can also pull out substrings. So echo $name, colon, and then the first number will be where you're starting from, and the last number is where you end from. So 0 to 4, we start at the beginning of the line, and we have 4 characters. If we do 3 to 7, you will get it will start at 3 and end at 7. We can also concatenate names together. When we do this, we echo the first name. You'll notice that we have quotes here to show the space. Again, if you didn't have a space here, it would ignore it. But when you print it out, you need to be definitive that you want just one space there. The other thing we can do is command substitution. And it allows us to take the input of a command or a program and save it into the value of a variable. So here we can see before where we did the arithmetic, it had double quotes. Here, we only needed to use single quotes. And these can become very complicated commands. You can use pipes to pipe them into other things. So if we run this, we echo the substring extraction, then we pull out just the best. So 0, 1, 2, 3, 4. Wile E. Coyote, we want to concat them 2 together. So we get the first name Wiley, space, last name. And then here we're listing, we're doing a word count of all the files that are in /user. And so we see that there's 13 entries in the user directory. So I've been talking about quotes. Linux has 2 types of quotes, the single quotes and the double quotes. I want to mention that there are other quotes called, I guess, curly quotes or special quotes that are used for writing more. And so if you copy and paste things, you need to be careful that inadvertently one of those fun quotes doesn't happen. So you want the straight single quotes and the straight double quotes. So the single quotes are going to preserve the literal value of everything inside the quotes. The double quotes is special because it's going to preserve most of everything in there, except it's going to recognize a special meaning of those special characters that we talked about before. So if you do double quote ABC, DEF, so var1 is going to get ABC and DEF. If we echo in the single quotes, it's saving the literal var1, var2, but if we use the double quotes, we get the ABC and the DEF. So backticks are not quotes, and they behave differently. So for those of you not familiar with the two commands, who am I and date, the who am I, if you type who am I at a command prompt on a Linux shell, it's going to return who you are currently logged in as, and the date is going to return the date, obviously. So we could use single quotes or double quotes, but if we do that, we won't actually get the response from the command. Input and output is very can be handled well in scripting. So a script can take one or more inputs and it can produce 0 or more outputs and or errors. There's a couple ways you can do input and output. You can input directly from the terminal, or you can use redirection. And with redirection, you can create new files, you can append to existing files. So in this example here, the read command is going to read from the command line. And then we're going to use these redirection operators, the double arrows, appends to the end of a file. The single greater than sign operator is going to either create the file or overwrite the pre-existing file. The double arrows will also create the file if it doesn't exist. So here are some of our redirection options. Just to note, there are 3 types of files. You can have standard in, standard out, and standard error. Excuse me. So the redirection is going to capture the output of a file, command, program, script, or code block and send it as input to another command, file, program, or script. So as I mentioned in the previous slide, the greater than is going to redirect the output of a file. It's going to create a new file if the file didn't exist before, or else it's going to overwrite that file. So you need to be careful when you're using this. The double arrows is nice because it'll just add on to the end of the file. The pipe, while it's not output necessarily, it's a command chaining tool. So it's going to take the standard out from one command and put it into the standard in from the next command. If you have the less than sign, it's actually going to redirect your standard in from a file. So it reads from the file. The ampersand greater than is good for debugging because it's going to redirect both your standard out and your standard error to the file. And as mentioned with the BC command, the triple less than reads directly from the value of the variable. So we can also get information, we can read in from the command line. So when you devise your code or your script, you can have the code and then you can add any number of variables in the command line itself. And then you can retrieve those using the $1, 2, and 3. Keep in mind that the $0 is the name of the shell or the script that you're running in. So that's a special character. You can't use $0. But you can use these other ones, very simple. And it also allows flexibility when you write your scripts. Here's just a little example. We have the backticks here. So we're doing a word count on the file that's in, then we're returning just the first field. We can see that we can do this for file 1 and it'll give us the output for file 1, and we can reuse the script for file 2 as well. So we don't need to write a whole new script. We can just change how we call the script. This is just looking at it the same way and just showing how to use redirection again. Before it had a few additional characters we had to. This simplifies it because we just use the redirection of the file, the first parameter that we inputted into the word count. And so this is just a little shorter. Now we'll come back and we'll talk about functions. So a function is just a block of code that performs some tasks that can be called multiple times for performing tasks. It essentially is enabling grouping usable code blocks within scripts. Uh, the syntax is pretty straightforward. You will give the function a name, followed by the open and close paren. Then we'll do squiggly brackets. You can have any number of commands and comments within it, and you'll close it. When you want to call it, you simply use the function name. And here's just a little quick example of how to do a quick hello world. Another strong feature of using scripting languages is the ability to use looping and branching. So looping and branching are control flow mechanisms. They allow you to reuse the code block by enabling the repeated execution of the code for using constructs. The constructs that we can use for looping are for, while, and until. We can also do branching, which enables conditional execution based on the specific criteria using statements. And those two statements are if and case. So if will execute code conditionally, and case is going to provide a multi-way branching based on pattern matching. So let's look a little closer at the while loops. So while loops are going to check for a condition and loop until that loop while that condition remains true. In this case, we did so while the condition and do, and then the commands and done. That's the basic format we have. In this example, I am going to loop over a series of numbers. So because I am doing the loop, and to avoid having an infinite loop, I have to have a counter in here. So I define my variable I outside of the loop. So while I will start with 1 is less than or equal to 3, we're going to do what's inside the loop. So we're going to echo the loop number, and then we're going to do the arithmetic function of adding to 1. So I plus plus brings it to 2. And we'll do that till while it's less than or equal to 3. So we get 3. So for loops are a little different. They let you iterate over the items in a list. The list can be defined in multiple ways. Lists are they're gonna iterate through each item in the list and assign the variable and executing commands within the do block of the code. So a list can be a sequence of strings, a range of numbers. It can be the output of a command, or it can iterate over files in a directory. So here are the 4 examples. So this first example is iterating over the files in a directory. The second one is essentially doing the same thing, but it's using a command to list the files in the directory. The third one is just iterating over a series of numbers. So this is going through 5 numbers. And the last, you can actually you can specifically define which files that are the variables that you are going to loop over, divided by white space. So let's talk a little bit more about iterating using numbers. If you need to iterate over a range of numbers, you can use 2 approaches. You can either use the seq command or the curly bracket notation. So the sequence command is simple, sequence 1 to 3. So we're going to iterate 3 times. For the curly bracket, it's similar, but the notation is slightly different. It's the first number dot dot to the last number. With both of these, you can go you can increase in size. You can also decrease or decrement. You can also do them as stepwise functions. And here are examples of going down, starting at 10 and going down by 2. So in the sequence command, the stepwise is the second parameter that's provided. And in the curly brackets, the stepwise is the third parameter that's provided. So we also can do decision-making using branching. So the decision-making uses 1 or more conditions for executing a block of code. If the conditions are satisfied, then the block is executed. If the condition is not satisfied, then it's not executed. The expressions produce Boolean results, so either true or false, and those are called conditions. So there's two types of decision-making statements that we can use within a shell script. You can use the if, else if, else, or we can use the case. So the if, else if are considered our conditional statements, and they're used to execute, I say two here, but you can actually have many more different sets of code based on how many else ifs you have in there. And then your case statements are decision statements, and they work as switch statements in a program. So it allows you to check multiple conditions or do string matching specifically. Excuse me. So conditional statements, your basic format is if condition, then statement. If always start with the if, and you can tell when it's done because it will have a reverse if, so the fi. You can have as many conditions as you want. So if condition, then statements, you can just have one. So you can do if condition else. And so it kind of falls through. If it's not the one, it will be the else. But you can have as many conditions as you want. So you can use condition 1, condition 2, condition 3, condition 4, condition 5, as many as you like. Note that the if needs to have the semicolon then, and all of the else ifs needs to have the semicolon then, the else does not. So your case statements is a little different. The basic format is you have a case, you have an expression you're going to compare, and then you're going to have various patterns and the code to execute in case those happen to be there. Excuse me, the star at the end basically says to capture anything else if none of the other patterns are there. So I copied this example from the web because I couldn't find a good example, but full disclosure. But this was a nice example that actually made sense. So if we use the echo enter, we can read from the command line, and then we pop into our case statements. So depending on what country we put in there, if there's Lithuanian, then it's going to write the official language of the country is Lithuanian. If it's either Romania or Moldova, it will be Romanian. And if it's Italy, San Marino, Switzerland, or Vatican City, it'll be Italian. And again, the star at the end is the catch-all. So if it doesn't fall into any of the other case statements, it will come down here and be unknown. Similar to the if statement, the case statement is ended with the reverse case. We mentioned the shell operators and the comparisons that we can make. So we can make comparisons in shell scripting. We can make decisions by doing comparisons on strings, partial strings, or numeric values. The string comparisons use logical operators to evaluate the sequence of characters. The numerical comparisons obviously use arithmetic operators to check for arithmetic-based conditions. These are some of the operators that are available out there. This is a good sampling, but I think there are definitely a few more that again, not comprehensive lists provided here. So let's look at numerical comparisons first. The variables, if they contain numerical or integers, they can be compared using the less than equal to, the greater equal to, or the equal to. In this example, you'll see that if 1 is less than 2, then echo 1 is less than 2. This also shows us the example of the if statements. We could essentially do if, else, if, but by doing that, it would fall directly out. So by doing each individually, we make sure that each one gets reviewed. So we're reading in from command line. We read into two variables. So 2 is equal to, is less than or equal to 2. It is greater than or equal to 2, and it's equal to 2. And so if you do 2 and 3, it will go on in that fashion. One thing to note, we did mention before that integer, by default, it's integers. So if we try and use a non-integer value, it will throw up on us. For string comparisons, they're slightly different because they can handle, they're going to compare using the lexicographical order. Um, so you can, again, since we don't have data types, the the interpreter doesn't know exactly what they are. So depending on the operator you use against it is how it's going to handle them. So A, B, C, D, E, F, you can see that ABC is not equal to DEF and ABC is less than DEF. If we do numbers, we can see that 1, 2, 3 is not equal to 45, which makes sense. But 1, 2, 3 is less than 45, which doesn't make sense. But again, because we're doing string comparisons, it's not, so you need to be careful to make sure that you're either using the arithmetic or the string comparison. So I think the last conditional statement I'm going to talk about is testing for existing files. So you can use conditional statements to test if a file exists, if it's a regular file, or if it's a directory. There's a lot more options, and here's a link to all the other options you can see. So in here, we can check for file in file1 tempter. We have a do loop here. If the file exists, then it exists. We can have nested if and else if code also, which this example is showing. So if is correct here, you can see that this if statement will be closed out at the very bottom, but then we also have this internal if statement. So if the file, then it's a regular file, or else it's a directory. I mentioned that there was the ability to do debugging with this code. It's a nice nice option, not with this code, but with scripting languages that you can debug. The options are you can debug on a whole script. You can also do it on the command. You can also do it inline debugging. So if you want to do the whole script, you can use the command line to add in the directive. So you would just bash -x script.sh. So the X is going to print the command traces before executing commands. So you can see line by line what exactly is happening and what the command was that produced the result. Recall at the beginning, we talked about that if you wanted to use any additional directives, you had to use the full path in your script. So in your script, you can modify the shebang command to add in additional directives. And this will do the same thing and will add in so that you can print command traces before, and it also prints the shell input lines as they're read. However, if you have a bigger script, you might not want to have all that output because it's just too much and it's noisy and it's not going to help you find out where your problem is. So you can do line by line debugging. Counterintuitive, to set it on, you use the minus or the hyphen, and to turn it back off, you use the plus sign. So one of the cool features about shell scripting we talked about is automation and the ability to, because it's a program, you can execute it programmably. And using cron, you don't even have to type the command. It will just be on the system and the system will automatically run stuff for you. So cron is the system's main scheduler for running jobs and tasks, and it's kind of asynchronous. So there's a command called cron tab, which allows you to submit, edit, or delete entries in the cron. And the cron tab file is where it holds all the scheduling information that you want to use. It should be noted that on most HPC systems, the system admins are most likely not going to let you use cron, but it's worthwhile to know in case you are a sysadmin yourself, you will have that ability. So the way it works is you can modify your cron tab file. You can set it up to run jobs daily, weekly, monthly, or on a specific time basis. So the first 5 fields specify when it should be run, and the 6th field specifies the command that should be run. In those first 5 fields, you can use ranges, you can use lists, you can use steps, and you can use wildcards. The other thing that I'll note is day of week goes 0 to 7, and 0 and 7, I think, are both considered Sunday. So this is just an example of I pulled from our system admin our cron tab. So the file is actually very large, and this is just a little bit of an example of what it is. But basically, it updates our ACLs on our system. It helps with the combining. If you guys are Access users, then you know that we connect the system so that you can log in. And so this helps us to map the TG is kind of a antiquated form. TeraGrid was before Exceed, which was before Access. But so you see, there's lots of things, and our system admins are actively using this. So the one thing I didn't mention at the beginning, because I didn't want to lose you right off the bat, is that nowadays with the large language models, there's an easy button to this. But it was important that you all join for this discussion, because you aren't going to know what to ask ChatGPT if you don't know what's available to you. But I tried a couple different ones of these, and these actually, most of them turned out well. The only thing to mention was, again, sometimes the quotes copied and pasted incorrectly. It's very nice. It gives you the script. It tells you how to run it. So kind of in summary, scripting is great for automation. It allows you to automate repetitive tasks and processes. This helps you save time and reduce the risk of errors that can occur when you do manual typing, so you avoid any fat fingering. It's great for portability. You can use it on Unix systems, Linux systems, Mac OS. You can even use it on Windows through some of the emulators. I meant to test it, but I wanted to see if it works in PowerShell. I'll have to test that. It's great because it's really flexible. It's really highly customizable. And because you can use it with other programming language, it makes it, again, really powerful tool. It's very accessible because you don't need to learn a different language. And on any Linux operating system, you're going to have some built-in shells. So you can always do shell scripting on Linux. It's great for integration because you can use it with other tools and applications. You can use it with databases, web servers, cloud servers. It's great for complex automation and system management tasks. It's also nice because they're really easy to debug, and they have the nice built-in debugging tools available with them. So in summary, learning shell scripting is going to help you become more effective user of advanced cyber infrastructure. While we gave you a broad sampling of what is available in shell scripting, this is by no means everything you have. I highly recommend testing it out. It's a lot of fun. If you want to go deeper into this, there's a couple resources listed here: Advanced Bash Scripting and Forums and Tutorials. And with that, I will stop sharing and opening it up for questions.